Good morning, afternoon, and evening, everyone, depending on where you're tuning in from, of course. I am Molly Pettit, and I head up developer relations at Elemental, the makers of Dagster. I am so excited that you've joined us for Dagster Day. We'll be making two huge announcements that mark a new era for the product, Dagster 1.0 and Dagster Cloud General Availability. In addition, we'll also be announcing some new revolutionary capabilities that we're excited to share with you. And if you're interested, you can find us on Product Hunt as of today. In a moment, I'll be playing a video we've created just for this occasion. We'll first be hearing from Nick Schrock on the evolution of Dagster, how we've gotten to where we are today, and what the future holds. We'll hear from Sandy Ryza on Dagster 1.0 and software-defined assets, as well as Rex Ledesma on the thoughtful determination of the Dagster Cloud pricing model. Along the way, you'll also hear from a few members of the team, as well as some happy customers and users. Then we'll wrap up with some live Q&A, where you'll have a chance to ask questions of the Dagster team. So be ready to jump in the chat. All right, now without further ado, let's get into this, shall we? Passing it on to Nick.
Hi, my name is Nick Schrock, and I'm the CEO and founder of Elemental, the company behind Dagster, the next generation orchestration platform for the development, production, and observation of data assets. Today is the culmination of years of work in partnership with our community and our customers. To everyone that has worked with us, given us feedback, and contributed, thank you. We are making two exciting announcements today, the release of Dagster 1.0 and the launch of Dagster Cloud. Let's start with 1.0. Dagster is in production at companies large and small, powering some of the most sophisticated data and ML platforms in the world. Our 1.0 release is a new milestone of maturity. The core Dagster framework is stable, battle-tested, and a solid foundation that the entire community can confidently build on. Second, we are releasing Dagster Cloud to general availability. Dagster Cloud has been in early access for 6 months, used by startups and Fortune 500 companies alike for mission-critical workloads. We are now excited to open up Dagster Cloud to the world, allowing anyone to sign up and deploy workloads to production. Before digging into the details, I want to talk about some of the challenges that we see in the broader industry. Every company is becoming a software company, and then in turn, to understand itself and drive better decision-making and outcomes, it becomes a data company. That means every company has a data platform, a set of tools and services where data originating from SaaS apps, operational databases, and the outside world is integrated, transformed, and managed. All too many teams are in a desperate struggle to manage their data platforms. Practitioners are overwhelmed, pipelines are too fragile, and tools are too fragmented. But there is progress. We see a new generation of modern data teams making enormous strides in efficiency and productivity. We see these teams converging on a set of principles. One, they use cloud-native infrastructure and managed services to minimize operational burden and elastically scale with their business. Two, they embrace software engineering and DevOps processes to manage complexity. And three, they model their platform in terms of data products and data assets. Tools aligned with these principles, cloud data warehouses, ingestion tools, dbt, reverse ETL tools are gaining wide adoption and delivering outsized outcomes for data teams. But orchestration has been largely left behind. The existing landscape is a menagerie of legacy tools and mindsets that modern data teams begrudgingly use but do not adore. And orchestration is critical. Without orchestration, there is no centralized control planes. Teams must schedule tools independently and hope and pray that they run on time and in the right order. When things go wrong, they are left to debug and diagnose in siloed tools. Data platforms without orchestrators aren't really platforms at all. They're an operationally fragile, siloed collection of tools where there is a constant confusion about what ran, what's supposed to run, and whether things ran in the right order. Now, with the full release of Dagster Cloud, there is finally an orchestrator and control plane designed for modern data teams. Why? Because Dagster Cloud is a managed orchestration service, you can now deploy Dagster effortlessly and securely to the cloud. Because Dagster Cloud is a productivity platform, providing a frictionless development workflow that embraces DevOps processes where you can maintain agility and productivity as you scale. And because Dagster Cloud is a unified control plane that provides a single pane of glass for data teams and their stakeholders. It provides operations, lineage, and observability for your data assets. With these capabilities, Dagster Cloud simplifies and consolidates your stack of tools into an operationally robust, coherent platform that is both easy to use and a joy to work in. We're excited to celebrate these milestones at Dagster Day. I am now going to introduce you to Sandy Ryza, the lead engineer of the Dagster project. He's going to discuss Dagster 1.0 and in particular, software-defined assets, our innovative declarative approach to orchestration.
I'm Sandy, and I lead the open source Dagster project. I'm extremely excited about the release of Dagster 1.0. 1.0 doesn't include any seismic changes. Rather, it's a major milestone that indicates we put the finishing touches on our core abstractions. Data teams who want to access what's unique about Dagster now have a stable foundation to build on top of. Dagster is different from other orchestrators. It's the first orchestrator that's built to be used at every stage of the data development lifecycle. Local development, unit tests, integration tests, staging environments, all the way up to production. And it's the first orchestrator that includes software-defined assets. It frees up teams to think about assets and let the orchestrator manage the tasks. Software-defined assets are a new concept, and they merit some explanation. At one level, Dagster orchestrates computations. You can define operations that you want to execute, specify dependencies between them, and schedule them. Dagster can replace a task orchestrator like Airflow without requiring significant shifts in your mental model. But the primary job of data teams is to develop, maintain, and operate data assets. An asset is typically a database table, a machine learning model, a report, any persistent object that captures some understanding of the world. For that job, orchestration is just a means to an end. Software-defined assets are a layer that can directly model the relationships between computations and the data assets that those computations produce. How do software-defined assets work? Let's dive in and find out.
Data teams manage complex webs of data assets. Even small organizations can have hundreds of tables and machine learning models, powered by thousands of lines of code, spread across a variety of technologies. This easily devolves into chaos. You don't know why your data is stale, and you end up with conflicting versions. You don't know what to trust, and making changes feels dangerous. Much of this chaos comes from managing data in an imperative way. You may keep your assets up to date using an orchestrator, but most orchestrators just launch tasks. They don't know what an asset is. Dagster introduces a declarative approach to data orchestration. The solution? Software-defined assets. Dagster lets you declare, in code, an asset you expect to exist. Instead of a task, you define the function to run to update the asset, and the names of the upstream assets that it depends on. Now, instead of asking whether your task ran, you can ask whether your asset is up to date. Instead of running a task, you can update an asset. You can identify assets that don't have definitions, and garbage collect them. You no longer need a monolithic object that specifies all your dependencies. Code becomes easier to manage, because each asset knows what other assets it depends on. Write the definitions in Python, or load them from external tools like dbt or Fivetran. Build a graph that spans all the assets in your organization, and use it to keep them up to date. Discover how software-defined assets can bring order to your data platform.
Alright, so we just saw the ideas behind software-defined assets. Now let's see how they work in practice. This demo will walk through how to get started with this programming model and the powerful features that it enables. Through it, we'll build out a sample data platform showing how to create our own assets in Python, as well as how to load them from external tools such as dbt. With that, let's jump into the code. Let's start from the very beginning. Our team wants to take some raw data and store it in a data warehouse. We'll start with a few imports, then define a function to generate our raw data. To keep things simple, we'll just grab some data from Wikipedia using pandas, but this is completely arbitrary Python code. We can use whatever libraries we want, and load, operate on, and return data of any type. By annotating our function with the asset decorator, it becomes an asset. The key, or name of the asset, is country population, and its contents are computed using the function we just defined. You'll notice that we haven't yet told Dagster how and where to store this data. We could include that logic in line, but it's often useful to keep this business logic separate from I/O concerns. By default, our assets will be stored as pickled files on our local file system, but this behavior is completely customizable, and Dagster has built-in support for storing assets with major cloud storage systems, such as S3, ADLS, and Snowflake. We'll come back to that in a minute, but for now let's spin up a web server on our local machine to view this asset in Dagster's UI. Because we've just defined this asset, its data isn't stored anywhere yet. We can kick off a run to fix this straight from the UI. We can monitor its status directly from this view, seeing that a run is currently refreshing it, or we can jump into a live updating timeline to view detailed logs as they come in. Once the run successfully completes, our data is stored and ready to be used. From here, it's natural to want to take our new data and do something with it. For example, we might want to use the raw population data and aggregate it per continent. This is where the declarative model really shines. All we have to do is define a function that takes our first data asset as input and returns some transformed data. We define a data dependency simply by adding an argument to our function with the name of the asset that we want to depend on. Once we turn this into an asset, Dagster will handle the rest, from creating a lineage link between these two assets to loading the contents of country population as input to this function when it comes time to run it. If we go back to the UI and reload our definitions, we'll see our new asset, which indeed depends on country population. We can now kick off a run to refresh one or both of these assets. While that's running, it's useful to take a step back and consider the benefits we're already getting out of this declarative model after just a few lines of code. At no point in this process did we need to think about tasks. We just wrote the code necessary to compute the contents of our assets, and the orchestrator was able to string these definitions together to execute them in the proper order. In addition, our orchestrator has direct understanding of the assets that it's responsible for, giving us insight into how they're computed and how up to date they are. Now that we have a couple of assets working smoothly, let's fast forward a bit and see how this scales. To keep everything organized, we'll break things out into separate files, then combine our assets into a single Dagster repository. First, we'll load in the population data assets that we just created. Now, we'll bring in a DBT project to transform and process our population data. We can load these DBT models as software-defined assets just by pointing Dagster at a local DBT project. Finally, we'll bring in a machine learning team that will use the data processed by DBT to train a machine learning model. These assets were defined in Python just the same as our original assets. Once again, the code inside these assets is completely arbitrary, and you can use whatever tools or libraries you want. With all these assets added to our repository, we now have a number of assets which are represented as pandas data frames in Python, then serialized as files on local disk. Instead of these pickled files, we might want these data frames to be stored to and loaded from Snowflake tables. We can tell Dagster to do that by importing a built-in I/O manager and applying it to our assets. You might have noticed that changing the storage location of our assets didn't require modifying the definitions themselves. This makes it easy to write unit tests for our assets, as the business logic stays decoupled from the external systems where the asset will be stored. Each asset can be assigned a different I/O manager, allowing precise handling of storage behavior. Now that we have some more assets defined, let's head back to the UI. The first thing we'll notice is that our original population assets now have some downstream dependencies. When we loaded our assets, we separated them out into different asset groups, giving us easy to parse views of data assets associated with specific projects or teams. Right now, we're just looking at the population group, but we can also look at the other groups of assets that we loaded. These are the DBT models that we loaded as assets in Dagster, containing all of the same lineage information as the original project. And these are the forecasting assets that we loaded from our machine learning team, which consume some of those DBT assets as input. If we go to the global lineage graph, we get a total view over all of the assets in our data platform. This graph spans groups, jobs, and code locations, giving you insights into your data dependencies regardless of how you choose to organize your code and execution. Clicking any of these assets will bring up a sidebar containing some high-level information about the asset. For example, we can see that this forecasted population table is partitioned by day, meaning each run only updates a single day's worth of data in the table, rather than recomputing everything from scratch. This is one of the many views throughout the UI that allows you to see which partitions have been computed for an asset, making it easy to tell if any data is missing. If we want to learn more about a specific asset, such as our population summary table, we can search for it by name and get taken to its asset details page. From here, we can see information on every time it's been materialized, its definition, and which assets it relates to. If we want to refresh this asset, we can do that directly from this page. We can kick off a run that rematerializes just this asset, or we can select its upstream dependencies and rematerialize those as well, to make sure it's as up-to-date as possible. This sort of workflow is also easy to put on a schedule. If we go back to our code, we can define a new job that targets a selection of assets that are upstream of our population summary table, and put it on a schedule that will run it once a day. Back in the UI, we can see our asset is now on a schedule, and the job we created shows up ready to be run. Altogether, software-defined assets and the tooling around them make it easier to understand and manage the state of even large data platforms. And with that, I'll pass it back off to Nick, who has some announcements about Dagster Cloud.
Sandy, Owen, thank you. I'd now like to talk about our managed service, Dagster Cloud, which we are opening up to general availability today. Companies big and small across the world have adopted Dagster open source. We are committed to developing and maintaining our open source product. It is critical to our success, and supporting our community is core to our values. But feedback is clear. Tons of users want a managed service with enterprise features and support. So first and foremost, Dagster Cloud is a managed orchestration service, whose goal is to minimize your operational burden with a platform that is both easy to use and that scales to the most demanding workloads. Today we are launching 2 hosted options, serverless and hybrid. Serverless Dagster Cloud frees the user from all operational burden, hosting all computation. Spin-up in serverless is totally effortless and provides an unmatched, fully integrated experience. Just write a Python file and we do the rest. No Kubernetes, no Docker files, no provisioning. But not all users can offload computation to a hosted service. For this, we offer hybrid Dagster Cloud. With hybrid, we host all the stateful system infrastructure necessary to run Dagster's control plane, and you bring your compute platform of choice. Dagster Cloud has no ingress into your infrastructure, does not see your code, and does not touch your data. You run a simple agent in your existing infrastructure, which in turn manages a stateless, elastic cluster that is easy to maintain. Hybrid Dagster Cloud maximizes flexibility and security while offloading the vast majority of operational burden to a managed service. After you have set up Dagster Cloud, you are ready to write and deploy code. And this is where you see the Dagster framework and Dagster Cloud combine to create a breakthrough engineering workflow for data teams. The current state of developer workflow and orchestration is highly unsatisfactory. You can structure your code for local development, but you are still limited in what you can test, as data pipelines depend on secrets, services, and data that are not accessible or runnable on your laptop. Teams either have to test in production or to set up heavyweight inflexible staging environments that are clumsy to use and costly to manage. Dagster and Dagster Cloud combine to provide a novel new type of environment, a branch deployment. It is a lightweight staging environment created with every pull request that becomes a focal point of development, testing, and collaboration. Let's talk about how this works. For most users, they have a main branch that contains their code, and a production deployment where that code is deployed. With branch deployments, you follow a familiar development workflow. You create a new branch, edit your code, and create a pull request. Then our out-of-the-box infrastructure takes over. On every push, it creates a lightweight staging environment from that PR where you can run and test your code. The Dagster framework is designed with this in mind and allows you to parameterize your pipelines and assets to point-to-test data in the branch deployment. In effect, you can branch your entire environment, providing a safe, collaborative engineering workflow on top of your data platform. When you have completed your work in your PR and validated your changes in the branch deployment, you merge your changes back to main, and then new code is deployed into production, and your branch deployment goes dormant. So, you've set up Dagster Cloud, you're developing and deploying code with newfound speed and confidence, and you're executing that code on a robust, managed orchestration engine. But Dagster's value doesn't stop there. Dagster is the single pane of glass for your data operations. Dagster Cloud's run timeline provides a full overview with real-time status. On a single screen, you can monitor all your data runs. This is the command center for your data platform operations, and you can quickly diagnose problems with surgical precision. With Dagster Cloud's asset graph, you not only have full asset lineage and observability, but you can execute operations directly in the orchestrator, so you can tame the sprawling complexity of your data platform. With Dagster's Launchpad, you can launch runs with a powerful but easy-to-use auto-completing editor, usable by all stakeholders. You can kick off runs as defined, or easily experiment with their configurations and observe the result. This barely scratches the surface of Dagster's UI and operational capabilities. Debugging runs, managing backfills, monitoring schedules and sensors, inspecting your assets are all done in easy-to-use, powerful UIs that are a joy to use. Security and access management are built in, with SOC 2 compliance and SSO for all Dagster Cloud users. For enterprise users, Okta and Active Directory integrations are available, along with role-based access control, and the ability to create multiple deployments under a single account. With Dagster, your team gets to regain full visibility and control over your data processes. So you've heard from me, the CEO and founder of Elemental, which is the company behind Dagster. In a shocking turn of events, I've said extremely positive things about our product and platform. But if you don't believe me, why don't you just hear from some of our early access customers?
Before Dagster, we didn't really have a formal orchestration tool, so we had a lot of ad hoc scripts. Nothing was very organized or kind of was aware of each other.
We started with an Airflow deployment doing most of our main data pipeline orchestration work. We just felt like we needed a more flexible tool than Airflow.
Coming into this, we knew that we needed some kind of orchestration platform to sort of overlay against all those jobs and sort of bring them all together and be able to express those dependencies between them.
We thought about using Airflow. We thought about just using Celery. Ultimately, what we liked about Dagster was the composability of ops and graphs and jobs.
The observability has also really enabled our engineers to quickly diagnose issues and view progress on their own. They don't have to ask me to go look into why a job is taking so long or if something's failed.
The reliability of our pipelines is a lot stronger now with Dagster, just with how things are put together and built, which makes us spend less time fixing things and more time building new things.
Dagster, from what I've seen, has been really good at being there when we need it to be and then getting out of the way. So Dagster has been reliable. We've been able to trust it to just get the jobs done.
Being able to operate multi-cloud with taking advantage of different clouds and different vendors and their underlying compute for the best possible use case for each scenario is super important for us.
We've actually been able to extend Dagster's core functionality to do things like coordinating between Dagster and other tools that we're working with.
The out-of-the-box GitHub branch deployments is a brilliant feature for developers, and not just for the hardcore developers, but for the sort of the people who kind of wander into our data platform and want to deploy a Python process. Being able to make code changes, push them into a pull request, and then go look at the changes in Dagster and run a dummy job, it's a game changer.
I think there's a lot of promise with software-defined assets. Flips it from being job-oriented, function-oriented, etc., to being asset-oriented. It frames it in a way that is more intuitive to the human mind, I think, really makes Dagster as a framework sort of stand apart from the other existing frameworks.
It could list all the benefits regarding, more testable code and more observability in the pipelines, but I think the most interesting one to observe was the sheer fun factor, where I could very clearly see that the developers were just much happier to work with it.
The UI was really sleek and lots of eye candy, which is really nice.
It gives you a simplicity on the far side of complexity, which is to say that there's a considerable amount of complexity and really great engineering work that's gone into the product. But in the end, it's so that the interface that developers have to use and that coders have to use is as simple as possible, but no simpler.
It was really simple to get up to speed. I had a quick walkthrough with the teammate, was able to get up and going pretty quickly setting up.
Right now we're onboarding some new people onto data engineering, and I think it's made bringing them up to speed a lot easier and a lot quicker.
It abstracts away lots of principles that I kind of had in the back of my mind but couldn't put into words in data engineering, and essentially gives us the freedom to work with them in a way that makes sense.
The Dagster team has been really awesome. I would say that was another big selling point when we were looking at orchestrators.
The Dagster folks have been incredibly generous with their time with us. So we've had an amazing experience working with people like Rex and others in the Dagster Slack.
In the Slack community, just anytime we have a question, people are super quick to answer us and help us out.
I've had multiple feature requests, just little tweaks that I'd like to see be addressed within a week or two of posting them on the Dagster Slack channel.
It's probably the smartest collection of human beings I've ever met in my entire life. No joke. They just hustle. They just know how to get stuff done. The rate at which the Dagster team is shipping things is phenomenal. They've definitely proven to me that they're capable of shipping extremely high quality software.
It's just something that has been built with the current needs of data engineering in mind.
Dagster just has that level of flexibility that I really see a future where we can lean into using Dagster to drive, at least coordinate everything.
We're planning on continuing to use Dagster as one of the cornerstone pieces of infrastructure that we use for effectively all data-related tasks.
Is the one orchestration framework out there that always puts the developer and the stakeholder first.
And now I'd like to hand this off to Ben and show a demo of Dagster Cloud.
Thanks, Nick. Let's take a look at how Dagster Cloud will enhance the productivity and collaboration of your data teams, and just how easy it is to get started. Let's start by seeing what it looks like to get up and running on Dagster Cloud, which we can do in a matter of a few clicks. As a user, I have the choice to use Dagster Cloud as a hybrid model or as a fully serverless solution. The hybrid model ensures your code runs entirely in your infrastructure. Dagster Cloud manages the operational burden, but never sees your code or touches your data. The fully hosted serverless option lets us productionize our code without having to set up any infrastructure. We'd like to get up and running as soon as possible, so we'll choose serverless. Next, we'll connect our GitHub account. We could load some pre-existing Dagster code, but we'll instead have Dagster Cloud template some example code in our account for us, automatically set up with CI/CD. Here, we have our example repo. Our code is automatically being deployed to our production environment from our main branch. Once the deployment is complete, we can view our code in Dagster Cloud. From here, we can rematerialize our assets, kicking off a run in the cloud. With our code successfully running, let's go ahead and make a change. We'll open up the source file in our GitHub repo. Here, we have a few software-defined assets. The first pulls a list of serials from an API into a data frame. The second filters down to serials manufactured by Nabisco. We'll add another asset which filters down to serials manufactured by Quaker. Now that we've made our change, we can commit it back to our main branch, and this will kick off another deployment to production. After a few moments, our new asset is live in production and ready to be materialized. Dagster Cloud is built to scale with the size of your data team and your data workflows. Let's take a look at what the development process on a more mature data platform looks like. Here, we've loaded the code you saw Owen build earlier, which utilizes software-defined assets to fetch and process some population data. By deploying our code to Dagster Cloud, we can ensure our assets are reliably up to date. But Dagster Cloud isn't just a platform to run your code. It's built to supercharge the entire developer workflow, helping your team build, modify, test, and deploy their data workflows with confidence. A change begins in the local environment, where developers write their code. Let's go ahead and expand on our existing set of assets by adding some assets representing country GDP. We'll start by adding some imports. Next, we'll add a country GDP asset. We'll pull some data into a data frame. Then we'll add the per capita GDP asset. We need to depend on our existing GDP and population assets. Dagster's programming model lets us specify them as inputs to the asset function. We'll join the input tables, compute the per capita GDP, and return it. We'll create a branch, commit our changes, and push up to our GitHub repo. Next, we'll create a pull request. Dagster Cloud's GitHub integration will automatically create a branch deployment, an ephemeral staging environment where we can run our work against real cloud services and test our changes. After a few moments, our branch deployment is ready. Branch deployments run against a forked environment that we can test against to gain confidence in our work. Here, we've configured our branch deployments to create a temporary copy of our cloud environment. This job creates a duplicate of our Snowflake schema. Our pipelines and assets are parameterized to write to this copy, so we can materialize assets in our branch deployment without interfering with production. I can now go ahead and kick off a run to ensure that my changes work, in a context nearly identical to production. Of course, these branch deployments scale with the size of your team. Every pull request spawns a new branch deployment. It's easy for me to get context into a team member's change as a reviewer or another stakeholder by viewing their branch deployment, where I can explore their jobs, their assets, and their runs. Once I'm ready to merge my change, deploying to production is as easy as simply merging the pull request. Once the deploy is complete, I can go view my new assets live in the production environment, ready to be materialized for the first time in production. Dagster Cloud is built to not only be the easiest way to productionize your data platform, it's designed to empower your team to develop faster and with more confidence. We want Dagster Cloud to be the right choice for teams with large and small. I'll hand it off to Rex to explain how this philosophy guided our pricing model.
As we launch a commercial offering for Dagster, we want to take a couple of minutes to explain the pricing, and in particular, the thinking behind how we decided to price Dagster Cloud. We want to offer a solution that would scale, so it would be accessible to all, from a solo practitioner looking to run a one-off proof of concept, all the way to the most demanding enterprise, looking to free its data team of orchestration infrastructure concerns. We know that pricing has to be straightforward and predictable. It should align both the platform and the customer with the correct incentives. We wanted practitioners to work with the framework, not against it. We never want you to compromise your engineering principles. For example, most commercial orchestration solutions charge per task, but this encourages users to consolidate their pipelines into a few large tasks. Likewise, billing per seat would prevent teams from including all practitioners. For these reasons, we price on the duration of computations that you run on Dagster Cloud. And naturally, when you optimize your computations, your usage also decreases. You pay less if you run fewer computations. You pay less if you speed up computations. And most importantly, you pay as you go. You can realize incremental value without committing to an upfront cost. With all this in mind, here's how we decided to price Dagster Cloud. First, we provide a simple self-serve option. You can get started straight from Dagster.io and get set up in a matter of minutes. We have one type of self-serve account, which includes everything that you need to run a single production deployment, which is plenty for most teams if you take full advantage of branch deployments. And there are no usage limits on any of our plans. You can have unlimited users and run any amount of computation to meet your data platform's needs. If you're looking to have us host and manage the control plane and data plane for Dagster, we have you covered with our serverless offering. We provide a usage-based fee per minute of computation usage,
billed to the second. The price per minute comes down as you hit certain usage levels. If you want full customization of your data plane, we have that option with our hybrid offering. We host and manage only the control plane for Dagster, while you select and manage the data plane in your infrastructure. Again, the billing is simple too. You also pay a usage-based fee. In either case, if you're a larger enterprise, there will be some additional things you'll need. In our enterprise offerings, we include unlimited production deployments. We also provide built-in security, along with single sign-on capabilities, as well as more granular user roles. Furthermore, enterprise plans have robust service level agreements for those mission-critical implementations. You receive higher levels of support and a dedicated account manager for your team. Once you decide to try out Dagster Cloud, we also offer a free trial. Drop by dagster.io, where you can get started on your own or connect with our account management team to discuss the enterprise options.
Thanks, Rex. Next up, we'll be hearing from a few members of the team on what excites them about working on Dagster. And after that, some of the team will be answering your questions during a live Q&A. See you there.
So I joined Elemental because I was really excited about the team and what they were focused on. Specifically, the problem set of making the lives for data practitioners a lot better.
I used to work as a data engineer, and there's a lot of parts of that job that kind of just suck. I spent a ton of time on certain weeks literally just restarting data pipelines by hand.
I spent a number of years in different data practitioner roles, working as a data scientist, data engineer, machine learning engineer. And in all of those roles, I felt like I was fighting against the tooling. I ended up spending something like 50% of my time not actually doing the job that I was hired to do, but building tools that would help me and my team do that.
I had felt the pain of the problem that Dagster solves, saw how much orchestration had to happen day in and day out to keep these data assets up to date that people were creating in the data warehouse.
I joined Elemental because I heard Nick on a podcast talking about there's no best practices, or even a lot of industries are struggling with the big complexity problem.
Testing in production, sort of making a small change, waiting a few hours and hoping that it worked. I could kind of think back to my time trying to get data and really think that there must be a better way to do this.
About a year ago, I got introduced to Nick and the Dagster team, and really was just kind of blown away and was like, wow, these people get it.
I actually used Dagster at my previous company. Things I enjoyed most about using Dagster in my previous role was just how kind of solid the software fundamentals were.
Coming to Elemental, I was able to actually spend all of my time thinking about these problems sort of from the ground up, rather than just applying patch solutions.
I've felt the pain from the other side, from the side of our users, and I find it very fun to try to address that pain with software.
A lot of us come from a background of using these tools. Those who don't are super interested in listening to users.
Every week, one of the engineers on the team is the community liaison, and they're responsible for monitoring the different channels in our Slack and going back and forth with users.
Really helps to make sure that you're not developing in a bubble. If you're so narrowly focused on that, it can kind of stray from, what maybe the users think is important.
It's really helpful to be able to just chat through people that are using a tool more intensively than I am and really get an idea of the sorts of things that they would find beneficial.
I think it's almost like a superpower for me as a designer to be able to just DM or talk to any of our community members through the Slack.
Every day I learn something new about a new technology or a new way of approaching a set of problems.
There's kind of this actual beautiful feeling of momentum where you release a big feature, and then for the next, let's say, couple weeks or month, you're almost sort of on autopilot as you hear feedback from how people in the community are using it, and then adjust, improve the feature in response to that feedback.
I think one of the things that I was struck by when I joined Elemental was just how experienced some of the members of the team are.
The deeper you go in the APIs, the more you kind of understand that the people making them have thought really deeply about the problem.
Just working with people who take a lot of pride in the quality of the software that is produced and don't want to cut corners.
Everybody is super smart, super nice, and super driven. A lot of times you can't get all three of those in one place.
It's a very friendly environment where we support each other and also learn from each other.
Everyone's super empowered to work on impactful things. Everyone is working on something amazing. I feel like our demo days internally are always so motivating and exciting because there's just like so many cool things all happening at once.
The team here is great, incredibly talented, empathetic, fun people to work with.
All right, and we're back for a live Q&A. Do you want to introduce yourselves?
Sure. Hi, I'm Nick Schrock. I'm the CEO and founder of Elemental, the company behind Dagster.
I'm Sandy Ryza, and I'm the lead engineer on the open source Dagster project.
And I'm Daniel Gibson. I'm a software engineer primarily focused on our cloud product.
Cool. So we've been. Oh, I have a mic. Thank you.
To rehearse this more.
Thank you. Yeah. So we have had some questions streaming in the chat. Feel free to add more questions. First, I'm going to start with why would someone choose serverless versus hybrid?
Yeah, I'll take that. We try to meet our users where they are, and kind of our frame of mind is for data practitioners, you want to offload as much ops as possible. Who wants to deal with it? So we recommend if you're kind of have no constraints and you can host your, you allow us to host your computation, use serverless. It is subject to some constraints. So, we don't offer kind of unlimited scaled out compute. So it's primarily used to orchestrate other SaaS services and do lightweight computation. Now, if you need to host within your infrastructure or you need massive scale, customized compute resources like GPUs, for example, then we recommend hybrid. So we offer the full range.
Cool. And would it be easy to migrate to Dagster Cloud from a self-managed instance in Kubernetes?
Daniel, you want to take this one?
Yes, absolutely. We have several early access customers who were on Dagster open source and Kubernetes, and they were able to migrate their workflows over no problem to cloud. One of the big design decisions we made is that code that works in open source should work out of the box in cloud. All you really need to do is add a new Python package, an open source Dagster Cloud Python package, and then it should work. So happy to answer more specific questions about K8s as they come up.
Cool. And how much community engagement do you have outside of Elemental? E.g., what proportions of PRs come from outside? What proportions of external PRs manage to get merged?
Wow, it's a very precise metrics question on our open source. I don't have those stats off the top of my head. I don't know if you do, Sandy. But I think that the core of the system is mostly maintained by Elemental team members, but there are incredibly important contributions made by the community, especially in the space of integrations. We have entire integration libraries like the Microsoft Teams and MLflow, and a bunch of other really other important libraries that are completely community driven. Databricks. Anything else to add to that? Do you have the numbers off the top of your head?
30 PRs a month.
Oh, we have 30 PRs a month. Look at this. Got people helping out. It's pretty good, I think.
Okay, we have more questions. How do branch deployments work on hybrid?
I think that might be another Daniel question.
Absolutely. So in hybrid mode, you have an agent in your cluster that's responsible for any parts of the system that require access to your code or your data. So what we did for branch deployments is we made the agent able to track sort of which of your branches are currently active and spin up compute temporarily, sort of dynamically up and down based on what branches are open and serve code based on that. Also, when you spin up code in a branch deployment, you can sort of branch within the code to know whether or not you're in a branch deployment and access different resources. So the agent kind of injects different environments for these different branch deployments versus full deployments and sort of keeps track of which ones are active so that it doesn't use too much compute at once. It's kind of a quick overview of how it works.
I also have to say what this team did on branch deployments and hybrid is an engineering marvel. It's incredible work. This type of workflow is available in front-end frameworks like Vercel, which we use, but to bring it to the orchestration layer for data platform teams was a
achievement. As you can tell, I'm extremely excited about branch deployments.
I appreciate the thought. Okay, ML ops and notebooks in production. What are your thoughts on that?
Oh, it's really going for the hot button issues. Notebooks in prod. I think it's safe to say that it's a controversial issue with many strong opinions. Some people think it should only be for ad hoc data exploration and analysis. But there are interesting projects like, for example, Papermill, which allows you to invoke a notebook like a function. We actually do have an integration for that called Dagster Mill. And I think in terms of future roadmap, we are thinking about how to, bring in notebooks into our system in a more seamless way, but no promises there. Anything to add on ML and notebooks?
Yeah, I think the main thing I would add is we want to meet users where they are. We can provide a set of tools and a set of opinions that help them figure out what to do, but people who are relying on notebooks, it's not in our position to say that they shouldn't be using them in production, and that's sort of the philosophy behind our Dagster Mill integration.
Okay. We have a request to talk about Spark integration a bit.
Well, it exists. People use it. I think the most notable thing about it, which I think is cool, is that all you do is write functions which take data frames and spit out Spark data frames, and it handles all these ops for you. Because if you ever use EMR or one of these systems, you have to figure out how to copy code into a cluster and do all sorts of crazy stuff. And this just handles that for you. And it also has interesting integration points. This thing called Step Launcher, we don't have to get into it, but some of our customers use that to completely customize the way their Spark runtime works. Anything else to add to that?
Yeah, just I'd add there's a few levels to our Spark integration. So we have a core Dagster PySpark integration library, which offers what Nick was talking about. And then we have particular integrations built with cloud platforms that allow you to run Spark. So we have a pretty mature and old Databricks integration, as well as a EMR integration.
Okay. How could we manage DAGs that each have their own unique package dependencies?
Yeah, sure. Well, it's funny you ask. We really did build the system with this in mind. So, you have in cloud, you have a deployment, and that can have multiple what we call code locations. Each of those correspond to a Python environment or a container where a set of jobs can live. And it's being extremely useful because you can have one code location that say corresponds to an ML team, which has dramatically different dependency needs than another team which doesn't need those ML libraries. So we've really thought about environmental separation, both between teams, as well as between the user code and the system itself. Did we plant that question? Or that's a real one? That was great. You can keep asking ones like that.
Okay. So this is a question of at what point to start using Dagster. So would you say that it's worth using Dagster if I only have a single data file that gets uploaded and a single visualization that reads from it? At what point does Dagster add more value than overhead?
That is not one we would have planted. No, I'm just kidding. No, it's a great question. I think honestly for a use case like that, it sounds like there isn't even a schedule and whatnot. Any of the orchestrators actually might be overkill for that sort of use case. I don't know. This is controversial, Sandy.
Yeah, I mean, this might be a controversial take, but I think kind of a central part of Dagster's design philosophy has been to be as lightweight as possible when you don't need its fancy functionality. So I think when you talk about using Dagster in that situation, it's essentially taking a function and adding a decorator to it, and then having the ability to spin up a web UI that allows you to basically track what's happened. So I think maybe I'm a bit of a over Dagster enthusiast, but if I was personally doing that, I would use Dagster just because I don't think it's that hard, and it actually does give you a bunch even at the sort of 2 steps in your data pipeline level.
Let's go with Sandy's answer on that one.
Any plans to support auth and RBAC in Dagit?
Auth and RBAC and Daggett. Great question. Currently, those are supported in Dagster Cloud. Almost certainly, RBAC will be exclusively a commercial feature. One of the reasons is actually it is complicated, and we'll get, there'll be tons of demanding features, and we want to be able to move super quickly on that. So we think that makes sense to stick in the proprietary domain.
Okay. Are you planning to add certifications for Dagster in the future?
Like, what type of certification?
Yeah, that's a good question. Oh yeah, we could talk about the Co-Rise course.
You want to talk about the Co-Rise course? Co-Rise course, Molly?
Well, this isn't through us, but Co-Rise is doing a course that is data engineering in Dagster. And that's starting next week, I believe. So you can check that out if that's something that you're interested in. All right. Sorry, I'm just looking for the next question. There's so many in here. Yeah, I was looking for it okay. So wondering, when do you start expanding and hiring outside of the US, say Europe?
We have no immediate plans to, but I highly recommend everyone become Dagster Cloud customers as soon as possible so we can grow the company and expand to all over the world.
And
we have a ton of users in Europe. That's right.
Mm-hmm. Should one approach I/O managers and serverless differently than open source? OS may move to GCS or great, but does serverless have its own recommendation given it's in AWS?
Yeah. So that part of the system is pluggable in serverless as well. And so if you want to store the outputs of your assets or your jobs in an S3 or a cloud provider, which you might want to do because they might be relatively sensitive depending on your use case, you can absolutely still plug that into serverless and kind of include the credentials for those providers in the image. Yeah.
Okay. And what degree in difficulty is involved transitioning from ops and jobs to software-defined assets?
I'll let Sandy take this one.
Yeah, so we've seen a number of users do it. I think when we talk about transitioning from ops and jobs, we wouldn't necessarily call it that because when you're using software-defined assets, you're often using ops and jobs as well. Every software-defined asset has an op inside of it, which is the computation. And you can build jobs out of software-defined assets that execute those or materialize those assets on a fixed schedule or in response to some sort of event. We have a guide in our documentation. I'd recommend taking a look at it. It's called Upgrading to Software-Defined Assets, and it has a lot of the details of what this process looks like. But ultimately, it's an incremental process. So if you want to bring software-defined assets into the picture, you don't have to suddenly throw away all your code. You can take one job and start annotating the computations with assets. And then go job by job, and then you can take graphs that you have of ops and use an entire graph to back an asset. The last thing I would add is that we don't expect all of our users to transition from ops to software-defined assets for a couple of reasons. One is that there are some situations that we believe ops are best suited for. And another one is ops are here and here to stay, and there's no it sort of comes down to whether the value of software-defined assets is useful for you.
I'll just add one thing to that. We want to make it clear. It's not like this is like it's two parallel systems. It's a layered system. So we had ops, we had jobs, which is kind of manually constructing a graph of ops for execution. We had a thing called asset catalog. And another way to think about it is software-defined assets is this layer which beautifully composes those components. So you don't have to build a DAG on your own. Assets contain ops. It manages interactions with the asset catalog for you. And it's kind of the thing that makes it all come together where the whole is greater than the sum of its parts.
All right. We have some questions about branch deployments. Are branch deployments in Dagster Cloud only supported with GitHub, or is that functionality available with other Git hosting services like GitLab?
It's a great question. So the GitHub, the GitHub integration is kind of the easiest way to go because we have a GitHub app and it's one click and whatnot. But we built it in a layered way that's just built on the available CLI tools we have, which can be in a relatively straightforward way integrated with GitLab, or any CI tool really. Some of our early access customers, we're pitching them branch deployments, and they're like, "This is the greatest thing I've ever heard of." But I'm using GitLab, and it was fine because they, fairly easily were able to integrate it with their custom CI system, and they use GitLab, and it worked fine. So definitely well supported.
All right. And how do branch deployments work with DBT, and what is running DBT in Dagster Cloud?
It's a great question. Do you want to say Daniel's offering?
Okay. I think you were talking about branch deployments.
All right. Well, I'll take it then. From our perspective, DBT is just another technology we integrate with. And it works nicely. So in that demo, for example, that Ben showed, and we have an internal demo about this too, which we'll publicize. It actually works beautifully with DBT because every time you push up in a branch deployment, you can kick off a job which clones a Snowflake schema, and then you can make DBT point at that. So you effectively have kind of an isolated environment for your DBT jobs. And then either you invoke DBT run, which is their CLI utility, and we just run that in our compute, or in hybrid to be your compute. And we also do have a DBT cloud integration.
To add to that, in DBT, it's typical to configure a set of targets, which essentially correspond to different environments that you'd run your models. So local, some staging environment or CI environment, production. And you can basically use resources in Dagster to line up your different deployments with those targets. So you might use a production DBT target in production and a CI DBT target in your branch deployments.
Okay. A single production deployment sounds quite limiting for standard plan. How would you want users to set up staging environments?
Yeah, well, we actually really think that branch deployments will eliminate the need for tons of teams to support a staging environment. And if you need a permanent staging environment, or you have a bunch of teams that each have their production deployments, we think it makes sense to have that be an enterprise plan. And let me be one more thing. By one deployment, again, what I mentioned before, it has multiple code locations. So some of our early access customers have single deployments that support, like many teams. So I wouldn't describe it as too limiting.
Okay, cool. We're just going to do a couple more questions because we're coming up on the hour. Has Apache Arrow come up for you yet? It's something that's come to mind for me when reading about IO managers and pickling data frames.
Yeah, for those of you in the audience who don't know, Apache Arrow is a really exciting technology. It's a standard for in-memory representation of data frames. And it's really cool. It allows you to transition data frames from one compute runtime to another without doing any copies, and it has fast in-memory execution. Given all that, I'm not sure if we've seen any Apache Arrow IO managers, but in which case it would persist. I'm getting in the weeds too much. Anyway, there's no the system's very pluggable and would work with technologies that support Apache Arrow, and I think. But we have no kind of explicit framework support for it. The users have to determine their own storage formats, and it's pluggable. All right, now I said something that Sandy needs to correct.
No. I was just going to say it should be fairly straightforward to take one of the examples that we have that takes pandas as the in-memory format and uses a CSV IO manager and change 2 lines of code to turn that into Arrow.
Okay. And then last question, any comments on what you plan next, or where do you see Dagster in a year?
Yeah, that's a great question. On the cloud side of things, I think we're really focused on, we're going to be focused on a few primary things. One is continuing to invest in the developer workflow and developer productivity. We think branch deployments are not only an immediate game changer for the entire data ecosystem, but we think it's like a really interesting point where you can integrate with other tools and implement all sorts of interesting features. I think that we're also going to be working on making serverless more accessible and more usable in more contexts. Right now, and discuss this later, serverless is early access, and we're rolling it out in tranches because it's our first, we're hosting people's computation. We want to make sure we're providing a good service. And we think we'll be investing a lot there. And then also more and more enterprise capabilities. We want Dagster to be as accessible as possible in as many contexts as possible. And that's kind of the focus here. Do you want to talk about the open source roadmap?
So yeah, for open source, I think there are a few areas that we're excited about, and we'll have a lot clearer picture in a couple of weeks after the dust has settled on 1.0. One of them is there's a set of observability improvements that have been requested for a long time that we're excited to have the chance to finally improve on. Around servicing configuration in Dagit, making it easier to understand what sensors are doing. A second area is integrations. One that we're particularly excited about improving is our Airflow integration. So it's pretty common that people are really excited about using Dagster, but they're at an organization that has Airflow installation, and they're not realistically going to move all their pipelines from Airflow to Dagster in one fell swoop. So I think there's a lot of opportunity to expand on the existing integration that we have and make it a better experience to use Dagster alongside Airflow. And then the last one, and the one that is closest to my heart, is sort of furthering the software-defined assets vision. We've laid the framework, but I think there's a ton of opportunity to make Dagster this really powerful tool, not just for running stuff, but for kind of this full end-to-end way of managing aspects of your data. So having the ability to build sensors and memoization that are all asset focused is a really exciting direction for us.
Okay. Oh, yeah. So that's where we're gonna stop with questions because we have extended the hour. What closing thoughts do you have to pass on?
Thanks everyone for coming, and also thanks for all these incredibly high quality questions. It's always fun to see the community so engaged and asking such great questions. So what's next year? So we have launched. You can sign up for Dagster Cloud today. You can sign up, kick off your own deployment, and you have a 30-day trial. So we're super excited about that. And just a reminder, we're rolling out two variants of this. One is serverless, which is totally hosted by us. That is early access, meaning that you might be put on a wait list as we're rolling out the technology incrementally. But we're super excited about that. And then there's hybrid, where you bring your own compute and there's no wait list there at all or anything. This is just beginning. We are really excited to have this cloud product out in public. We're really excited to get that fast feedback loop with all our users. And I think you'll see our innovation speed increase. And we just have a ton of exciting improvements ahead. I just want to say thank you to the Elemental team who has put their blood, sweat, and tears into this thing. Well, I don't know if anyone's crying, but metaphorically, and we're bleeding. But the team has been working incredibly hard, and I think that it shows today, both with the features we're pushing out, as well as this. I'm in a TV studio right now. This is crazy, but just an amazing event today. And then, I just want to thank everyone for coming, and thanks for taking the time to listen to what we have to say. And we hope you enjoy our product. We're incredibly excited about it. Thanks.